Um, Good morning, students. I welcome you all to Brihan Mumbai Municipal Corporation Education Department online education for English medium. We are conducting for class 9, subject science, and the topic which we are going to conduct today is current electricity. And in that, the subtopic which I'm going to take today is electric circuit, conductor and insulator, and all the numericals based on Ohm's law and resistivity. Today is the third session of this chapter. My name is Ms. Bushra Maksud Ahmed and our Chief Nodal Officer name is Mrs. Almaz Hanouri. So today, the chapter number 3, that name is current electricity. Okay, in the previous session, that is session number 2, we have seen what Ohm's law, what is resistance, and what is the resistivity of the conductor. Okay, so today initially we'll do a short recap of the topic and then we'll go to our today's topic. So first we'll see resistance and Ohm's law. What the Ohm's law I have taught you in the last session, students. We will revise it again. Let's see what's that. The relation between the current flowing through a wire I and the potential difference across its ends V can be obtained from the law that was given by a German scientist, Simon Ohm, who has just stated this law, Ohm's law. The scientist's name was German scientist. The name was Simon Ohm. And in the honor of his name, the unit of the resistance is given what? Ohm. Now, what was that law? The law was, it was a relationship between the current and the potential difference across its end. Now, what was the relation between them? If the physical state of a conductor remains constant, the current I flowing through it is directly proportional to the potential difference V between its end. Okay, so I have taught you what is physical state. Physical state is nothing but length, area of cross section, temperature, and material the conductor is made up of. If all this physical state of a conductor remains constant, at that time the current I flowing through it is what? It is directly proportional to the potential difference. Now, what is the symbol of current? I, capital I, right? And what is of potential difference? V. So see, in the equation we have seen I is directly proportional to V. Directly proportional to V means if I will increase, V will increase. That is, current will increase, potential difference will increase. If current will decrease, potential difference will decrease, and vice versa. Now, when I remove this proportionality sign, I is equals to K into V. K constant terms comes, okay, and K is nothing but constant of proportionality. Whenever the proportionality sign is removed, equal to and constant terms comes in that. Now, the K is in which hand side? Right hand side. When I'll take the K from right hand side to the left hand side, it will go to the denominator, right? So I into 1 upon K equals to V. Now what will substitute? Will substitute in this equation 1 upon K equals to R, capital R, that's equals to resistance of the conductor. We have take what? R as a resistance of conductor. And resistance of conductor, I've explained you what is the resistance. It is a hindrance, it is an obstacle, right? It is not allowing current to flow through the circuit, and it's helped sometimes or every time to save the circuit when a high amount of current is flows through it. Now, as I put the value of R in the equation, what I get? V equals to IR, or R equals to V upon I. This is nothing but a Ohm's law, which we have learned in the last session. Okay. Now, I hope this is very clear to you all. Now, we'll go to the next one, that is resistivity. Now, what is resistivity? Now see, at a given temperature, the resistance R of a conductor depends on what length, area of cross section, and the material it is made up of. This we have seen. Now, how it is dependent? R is directly proportional to the length of the conductor. Then R is inversely proportional to the area of cross section. Therefore, R is directly proportional to L upon A. Means if length will increase, resistance will increase. And if area of cross section will increase, resistance will decrease. When I remove this proportionality sign, what I get? R equals to rho L upon A. Now the rho, small p symbols, you see it look like a small p. So that is nothing but it is termed as rho, and rho is nothing but it is the resistivity of the material. Rho is a constant of proportionality and it is called resistivity of a material. The unit of resistivity in SI unit is ohm meter. We have seen in the last session, see how the rho SI unit is ohm meter. We have calculated it, right? That how this ohm meter comes. So whenever it is asked that what is the SI unit of resistivity, so you will say it is nothing but ohm meter. Now see, resistivity is a specific property of a material and different materials have different resistivity. Now see, we have taken some examples also, right? Copper, nichrome and diamond, they all are having different resistivity. So so it depends upon the material. All the resistivity is depend upon the material the conductor is made up of. So hence different materials have different resistivity. Now this all is about the revision. Now we are going to see our today's topic, that is electric circuit. Now let's start it. Now see, what is electric circuit? Now see, a continuous path of an electric current through conducting wire connected to the two end of a cell and other resistances is called an electric circuit. Now you will tell me, ma'am, just you have read it, we don't understand what you mean to say. Now see, a continuous path. What is continuous path means? Continuous path means the path is not broken up, it is not open, it is closed one. So the continuous path of electric current means when the electric current is passing through it, none of the space is broken. The path is fully continuous. Through what? Through a conducting wire. Now where the conducting wire is connected, it is connected to the two ends of the cell. We always seen a cell positive and negative terminal. So always the wire is connected to positive and the negative terminal of a cell, and other resistors are also attached in it, so that the complete path, the continuous path of that electric current consists of conducting wire, cells and other components. Here just the resistance are there, but there are number of components we can add, right, in electric circuit. So this all is nothing but a electric circuit. Now see, the figure is on the next slide. I'll explain you that also. Shows how different components are to be connected in the circuit by using special symbols for each of the component. Now see, we know how the cell look like. We know how the ammeter look like. We know our wires, how it look like. But whenever we are drawing the electric circuit, is it necessary to draw the exact figure? It will be very difficult for us, okay? If we have to draw a cell, so we have to draw a huge cell. Others, so there are many small symbols, right? Specific symbols for a specific components that are used to draw in an electric circuit. An electric circuit is what? It consists of different components that are connected in it. And how they are connected? We are connecting it using a what? Using a symbols, specific symbols. Now such figures is called an electric circuit diagrams. Now the diagrams which are drawn with the help of the special symbols of each components, that diagrams are called was electric circuit diagram. See, mark my words, students. In electric circuit diagrams, what symbols of the components are used? We don't draw the whole figure of that component. We just draw the symbol of that component. Now, see the last point in that. In the circuit, an ammeter is used to measure current and voltmeter to measure a potential difference between the two ends of the resistance. As the voltmeter has a very high resistance, only a very small current flows through it. Now see, we'll see word by word. In a circuit, now see, in a circuit, what ammeter we are just we are connecting ammeter. So what is the purpose of connecting ammeter? Ammeter is used to measure what? It is used to measure current. Okay, students, always remember to measure a current, which device is used? Ammeter is used. And to measure a potential difference between the two ends of the resistors, always remember potential difference is measured between the two ends of the resistance. Now you will tell me, why ma'am it is always measured between the two ends of the resistance? Now see, if resistance is connected in a circuit, so the current flowing, the input of the resistance will be half high amount, while what is the purpose of resistors? He is opposing the current to flow. So the current which we get from the output will be less as compared to the input. Hence there will be what? There will be a potential difference between its two terminals. Hence, whenever we have to calculate the potential difference, we are connecting voltmeter to the two ends of the resistance, so that the potential difference should be measured. Now you understand why voltmeter are connected to the two ends of the resistance? Because I'm repeating again, the current input to the resistor is high as compared to the current output from the resistance, right? Because what is the purpose of resistance? He is opposing the current to flow. Because hence there will be what generate? There will be a potential difference generate. Hence, voltmeter is always connected to the two ends of the resistors. This point is clear to everyone. Now we'll go to the next one. Now see, as the voltmeter has a very high resistance, only a very small current flows through it. Now see, voltmeter has what? It has a very high resistance. It has a very high resistance, so only a very small current will flow through it. If very small current will flow through it, then only he can measure the actual potential difference of the circuit, right? If potential difference has a very low resistance, then all the current will flow from voltmeter only, right? So he will not able to measure the potential difference. Hence, always the voltmeter has what? It has high resistance, and hence a very small current flows through it, and it is useful to measure potential difference. I hope all the 4 points you all have understood. Now we are going to what? This is how electric circuit looks like. Now see, here are some symbols. In the next slide also I will show you all the symbols. Now see here, can you see the cell? Here we are having a thin and a big line of cell, that is positive, that positive terminal termed as anode, and a thick and a small line that is nothing but a negative terminal of a cell, that is cathode. Now see, can you see the switch here? The dot is in the between, it means the switch is on. The switch is connected. Okay. When switch is unplugged, when the switch is open, no current will flow through it. The circuit will be open at that time. When we switch on it, we close the circuit and the current started to flow in the circuit. Now see here about, now see whatever lines you are seeing, the arrows, that are nothing but are connecting wires, and arrows are showing the electric current flowing from the circuit. Now can you see a circle in which capital A is written and its two and positive and negative is written? This capital A is nothing but what? Is a symbol of ammeter. Ammeter is always connected in the series with the circuit. Now see why it is connected in series with the circuit. If it is connected in series with the circuit, hence he can actually measure the amount of current flowing the circuit, right? So hence ammeter is always connected in series with the circuit. Now can you see this crisscross line here? That crisscross lines are nothing but what? Resistors. Resistance, symbol of the resistors is like this crisscross lines with zigzag lines, okay? And a capital R is written near the resistance. So this is always a symbol of a resistance. Now see, I have always shown you that, I have explained you right now that voltmeter is always connected with the parallel to the resistance. Why it is connected to the parallel to the resistance? Because he wants to measure the potential difference between the 2 points of the resistor, the input and the output, right? And it is the voltmeter is having high resistance, so the current are not able, the high amount of current are not able to flow from the voltmeter, and he can easily measure the potential difference of the two ends of the resistors. Okay, so see here the circuit is closed. I have what is electrical circuit? Electric circuit is a continuous path for an electric current to flow through it, consisting of conducting wires and all other components. And these conducting wires are connected to the two ends of the cells. Okay, so I think this much my all students have understood very nicely what is electric circuit. Now we are going to mistakes in the electric circuit. Now students, very clearly you can see that the first this figure consists of what? Cell, conducting wires and a small bulb. Now see only the first figure and the last figure, that is figure A and figure F, the bulb is lightened up, while the other bulbs, figure B, C, D, E, the bulbs are not lightened up. So why it is so? See, to always to flow the current in the circuit, what I have told you, the circuit should be continuous, it should not be broken up. Okay, so if anyhow the circuit is broken or the circuit is open, the current will not flow through it, hence the circuit will not complete. So to complete the circuit, it should not be open up. Now see, we'll see in figure A. Now see, the red wire is connected to the green wire. The first wire means the positive terminal of the cell is connected to the terminal 1 of a bulb, and second terminal of a bulb is connected to the negative terminal of the cell. So it is making a closed path, it making a complete circuit, hence bulb glows. Now you will tell me, ma'am, what is the mistake in B? Now see, the first two wires are connected, means positive terminal of the cell and terminal 1 of the bulb are connected, but see the below wires, the two wires are broken up, and the circuit becomes open and the current will not flow in the circuit. See in the third figure, that is C figure, in that the below two wires are connected and above two wires are opened. Hence the circuit becomes open up and current not flows through it. Now see the fourth figure, D1. All the two terminals of a bulb is connected to only a negative terminal of the cell, and see the above terminal of the cell is open up. This will also not be happen because see the above terminal is open, hence the circuit is incomplete and no current will flow. Same in the same scenario is in the E figure. All the two terminals of the bulb is connected to the positive terminal of the cell, and the negative terminal of the cell remains open, hence no current flows. No current flows, circuit is open, right? Hence it is incomplete. There is a mistake in this electric circuit. Now see in the D1. Now see, in the first figure, the first terminal of the bulb is connected to the positive and second terminal of the cell is connected to negative. Now we will reverse it. The first terminal of the bulb is connected to negative and second terminal of a bulb is connected to positive. Vice versa, it is connected only, it is complete only, right? Current will flow through it, because in bulb there is no positive and negative terminal. There is only two terminal, terminal 1 and terminal 2. So whether in the two terminal we join positive negative or negative positive, the circuit will be complete. Hence the bulb glows in figure A and figure F. So we understood now what mistakes we don't have to do when we are making an electric circuits. Now we will go to our next point, students. Symbols for components of an electric circuits and their uses. Now see, what are the symbols of this electric circuits and what are the uses of it. Now see, number first component is electric cell. Picture, we know how it is look like, and what is the symbol? The big line is the positive terminal and small is the negative terminal. What is the uses of this electric cell? To apply a potential difference between two ends of a conductor. Okay, always to apply a potential difference between two ends of the conductor. Number of time I've explained you this. Okay, without battery no potential difference will occur in the circuit. Now when we require a numbers of cell batteries, okay, so see, what are batteries? Batteries are not collections of numbers of cell. When numbers of cells are connected in a circuit, what, see, the symbol looks like this. We have a continuous symbol of a cell: positive negative, small line, big line, small line, like this. Okay, and the positive side is termed as the positive terminal, and the negative side, small, is we find it as minus, that is negative terminal, cathode. Now what is the use of using battery in our circuit? To apply a larger potential difference between two ends of the conductor. When we required again a large amount of potential difference in an electric circuit, we need a collections of numbers of batteries. Okay, now we'll go to the third point, open tap keys or a plug key. Now see, open tap keys.